Triola, Elementary Statistics, 13th edition, Pearson. Chapter 8, Cumulative Review Exercises, Number 1 and Number 2, Part 1. Okay, so we're going to look at the first problem where someone has designed or planned a study. All right, so we planned a study and we're going to observe the number of lightning strikes. So the part of statistics that we learned is about planning either an experiment where we apply a treatment and we have control groups, or we plan a study where we're just going to make observations and then we're going to collect that information from the study or the experiment. And so it's all about planning, collecting, and we collect the data, which is just the information that we either observe or the results from test from the treatment. And then we want to organize it. And then we're going to maybe present it graphically. We could analyze it. What does that information tell us about the situation that we're interested in? And then we could actually go and make conjectures and hypotheses, and we can actually test and infer about maybe a little bit larger population than the sample we're able to include in our treatment, our experiment, or our study. So we're planning a study, we're collecting the data. That data has been collected for us, but right now I want to organize it. So I noticed that the variable I'm collecting information about is the number of deaths. That's a little morbid. From lightning strikes. And in particular, I'm looking at just the US. So I don't want to infer beyond the limitations of my sample. So these are a few values. Let's see, a statistic that I'm collecting first is I notice we've decided to only collect the number of deaths from 14 years. So this is my sample size. And any value coming from a sample is called a statistic. So here's my first statistic, sample size. I use a lowercase n, but I need to really organize this data. So I've made a number line, and I just want to see how these values are distributed along the number line. I have 51 occurring, so 51 deaths, 44 deaths, 51 deaths, 43, 41, 2, 3, 32, 48, not like I'm singing, that's kind of a sad song, 45, 27, so 30, 29, 28, 27, 34. So if you want to go ahead and do this for yourself so that you can replicate this on your paper or in your tablet, I have 29. We're almost through the data, 26, 28, and 23. So 23, 1, 2, 3. So I noticed that there seems to be a group down here and then another over here. So I'm already starting to see a little bit of pattern. And it was interesting how they distributed themselves. So the distribution of the number of deaths and lightning strikes seems to be spread in between somewhere in the 20s, mid-20s, lower 20s to lower 50s. And so some other statistics I observed right away that I didn't pick up on when they were just listed in order of year was that the minimum number of deaths seems to be 23 deaths in one particular year. And another statistic that I can now clearly see is 51 being the max number of deaths per year. And let's label this dot plot. I like titles for x being the number of deaths. This variable x is a count. So just to review, I'm going to collect that data and then represent it in various ways depending on what type it is. This variable is quantitative because it's a number representing a count or measure. I'm counting, so it's also discrete, versus qualitative, which would be labels or names. Discrete counting, you could also say that this is along the lines of a ratio level because 0 has a meaning here. If I observe 0 deaths in a year, then x's value of 0 has a particular meaning, and I can take a ratio now that you have a value or a meaning to 0. Something that wouldn't have a meaning of 0. Let's see, 0 time, that has a meaning, 0 temperature. But there are definitely some things that don't have a meaning when you have 0. Just not thinking of any right away. If x equals 0 has a meaning, it's ratio. But I digress. So we have quantitative, discrete. I can use a dot plot to represent this. Now notice I've got a scale here, but I'm kind of losing some of the values. Another way to represent this is with a stem plot. So I thought I would quickly do a stem plot just to refresh your memory. Everything but the last digit is going to be the stem. The last digit is going to be my leaf. I have values in the 20s. I have values in the 30s, in the 40s, and in the 50s. So not quite a long stem plot. Remember, we could break these values into 20. I'll just go ahead and put it so that you can see if you have quite a few values, you can break your stem in half. So I'm going to try to do that as well. Let me go back up here and just use the data. So this is the value 23. Oh, my stem, everything but the last digit. So I shouldn't have anything but the tens digit there. Whoops, I'm going to erase. That just drove me crazy. So 23. 20, that becomes the stem. 3, the ones place, becomes the leaf. I have 26. That's greater than 5. So I have 2 rows I'm using for my 20s. 0 through 5, and then let's do 0 through 4, and then 5 through 9 will be on the second. And so I have 26, I have a 27, I have a 28, and a 29. I have in the 30s 32 and 34. Both of those are less than 5, so they're going to go in that first row. In the 40s, I have 43, 44, and here's the 45. And I have a 47, is that 47? 46, 47, 48, that's a 48. Okay, and I have a 51. I have another 51, and this should be 14 values. So let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm missing somebody. So let's see. 23, 24. Where's my 24? 25, 26, 27, 28. 26, 27, 28, 29. And then I have 32, 34. I have 43, 44, 45, 48, 50, 51. I'm missing a value. So I'm going to quickly go over here and just look. So I should have a 51, 44, a 51, 43, 32, 38. Ooh, I'm missing a 38. All right, so did I miss him up here on the dot plot? Yes, 38. That's going to happen. So 39, 38. I should have 14 dots on my dot plot. My stem and leaf plot, glad I checked. I need a 38. Now I have 14 values, and this looks a little more together than the spread out dot plot. Now I'm seeing kind of a distribution which spikes up here in the 20s and then trails off toward the 50s. So more like a grouping here in this interval and then trailing off to the right side of my number line. So almost like my distribution is tending toward a right skewed distribution using the stem plot. So different presentations are going to give you or reveal different patterns. Now with the stem plot, I'm going to move toward, let's find the median. Median is a statistic, so another value coming from my sample, and it's the value in the middle of an ordered list. So I have 14 values, so 1, 2, 3, 4, 5, 6, 7, 7 in the lower half, so this would be my lower half, and then my upper half of values. So half meaning 50%. 50% are below, 50% are above. The halfway mark, so 1, 2, 3, 4, 5, 6, 7, is in between 34 and 38. So this median, the value of 50% below and 50% above, in other words, the second quartile, so it is also the 50th percentile. All these are synonymous. Would be the average of 34 and 38. So I have 72 divided by 2. So what is that? 36? That seems right. 36 is the median. So one of the statistics, I have min, max, median is going to be 32 deaths. Notice all of these statistics, min, max, and median, are in the same units as the observations, and the sample size was in years. And they didn't ask for the quartiles, but I'm sitting right here. So let's find in this lower half, what value cuts it into the 25% of the values below, 25% above. I have 7 values, which is odd. When it was 14 values, I ended up having to take an average. When it's 7 values, I count 1, 2, 3. He's in the middle, which is 28. 1, 2, 3. So the value that we consider to be the first quartile, or equivalently the 25th percentile, is going to be the value sitting there in the middle with 3 values below, and so that is 28. That's another statistic. Again, 7 values in the upper half, 1, 2, 3, 4, 5, 6. So this, what? 1, 2, 3, 4, 5, 6, 7. Whew! 7 are in the upper half. So 1, 2, 3 are below 45, and 1, 2, 3 are above 45. That makes 45 our third quartile, our 75th percentile, and we're going to write that value was 45. So I've got the median. Let me put out some more statistics. Q1 was 32. Oh, sorry. Q1 is not 32. What was Q1? Q1 was 28 deaths. The third quartile is, let me go back because my memory, 45. That means the middle 50%, which we're calling the interquartile, inter meaning between, quartile range, the middle 50% occur between 45 and 28. So that range of values, so 45, the third quartile, minus 28, the first quartile, gives me a distance of, so 45, 28. I'm just not very good at this. If this were 30, that would be 15. So I'm going to go with 17 deaths. All right, so that gives me statistics. Now let me go back to the problem really quickly. They asked me for the mean, the median, the standard deviation, the variance, and the range. Well, so far, I've just found the median. And I could add range. Range is the distance between the max and the min. So I erase that. So range is some idea of how far apart the values occur. And so max is 51 minus the min, which is 23. So if this were 50 and this is 25, that would be 25. So it's going to be 25, and then, so, oh boy, 23, 24. I believe this should be 27, 28. Oh, it's just really, I need more coffee. So we've got the range. In order to find the mean and the standard deviation and the variance, I'm going to need to find the mean first. So we've got a list of statistics started here. This is my attempt to kind of analyze the data, to try to get an idea, a feel for it. I'm going to add to that list and calculate the mean. Now the symbol for mean is X bar. And what we're going to do to calculate the mean is that's when you add up, so big sigma, all of the observations. And so I have 14 of these. So you'd start with the first one and add up big sigma sum all the way to the 14th. And then you would divide by 14. So that's how you come up with the average. Most people know how to do this. So you would add up all those values, grab your calculator, come up with the sum of all of these 14 values and divide by 14. Now the sample variance, I'm going to say that's standard deviation. Variance is how they vary. Really, we derived this idea in class. It's how far on average the values differ from the center, the mean. And when we take this, we square those differences, and then we end up dividing by one less than the sample size, because it gives us a more accurate value for the variance. But it's not in the same units. This is actually going to be in deaths squared. Let's see if I can write this. And I'm going to do this off camera in the calculator and then come back. So this is in a weird unit, deaths squared. This is variance. And then we take the square root of variance and end up with a standard deviation. So on average, how much do each of these 14 values differ from the center? How much wiggle room are we looking at as we move from one value and its difference from the average of all 14 values? So the symbol here is S sub x. I'm going to again use the calculator. I'm going to go to my TI. I'm going to use stat, and I'm going to use the edit mode. And I'm going to enter in all 14 values into list 1. Then I'm going to go back in the stat button. I'm going to use the arrow key and highlight the calculate menu. And this is a single variable, just lightning strikes, and I want to calculate the statistics for it. In this list, so after you hit stat, calculate, 1 var stat, make sure that your X list is the list where you enter the data. In my case, it's going to be list 1. And in class, we've had a few variables throughout the semester where we've given the frequency as well. These are each occurring with frequency 1. So make sure that frequency is blank. Don't put a list there. And then paste that to the main screen and hit enter, and I'll be back.